Hey everybody. For this lab, we're doing the empirical formula of a compound. Now, this is a pretty self-explanatory lab, but I'll give you one or two tidbits to help you out here. Now, you should, of course, read the lecture, or you should watch the lecture chapter on this particular topic, and you should read the book so that you have a better understanding of how to go about this process. This lab does have good information for you on how to actually calculate the empirical formula. And then, of course, I gave you some data. So you have some numbers there. And that's all you need. And then there's the critical thinking page. So in this lab, you guys are going to solve for the empirical formula of a magnesium compound. Long story short, you are going to burn some magnesium inside of a crucible. So that's a flame, Bunsen burner. You're going to have a crucible with a lid, and you're going to put some magnesium inside, and you're going to heat it up. Oxygen from the air is going to add to this compound until we end up with a new compound that contains both magnesium and oxygen. Now, the difference between a molecular formula and an empirical formula is just in their ratios. An empirical formula is the simplest whole number ratio, where the molecular formula may not be. I'll give you an example. Here is the simplest formula for hydrogen peroxide, 1H to every 1O. In reality, hydrogen peroxide looks like this, H2O2. It's just a simplified version, right? Another example, CH2O is the simplest formula for carbon, hydrogen, and oxygen in a sugar. The real formula is C6H12O6. So you can see if you multiply the empirical formula by 6, we can get the real formula for sugar. And if you multiply the empirical formula for hydrogen peroxide by 2, we get the real formula. Now, some empirical formulas are just already the same as the molecular formula. The formula for water, H2O, is already reduced as simple as you can get it, but we only need to multiply that by 1, or not at all, to get the real formula for water. So why are we doing this? Okay. We want to know this, the real formula, the molecular formula. But experimentally, we can't figure that out. Experimentally, all we can figure out is the empirical formula. And we can do that by knowing the weights of the two elements involved. And if we can figure out their weights, we can figure out how many moles there are, and then how those moles relate to each other. Whether it's 1 mole of hydrogen to 1 mole of oxygen, or 1 mole of carbon, 2 moles of hydrogen, 1 mole of oxygen, and so on. So that's what you're doing in this lab. You've been given some masses. From those masses and your brains, you're going to think about how much magnesium there is and how much oxygen there was. Once you know those numbers, you're going to calculate the moles and the empirical formula as according to, the procedure here. You can see this walks you through the steps. So here on this page, it's showing you how to go from grams of some substances into moles of substances. On the next page, they're showing you an example of how you take those moles that you calculated on the previous page, and you figure out the ratio of those elements to each other, and so on. And I really suggest that you guys watch the lecture video on this topic, and I think I even posted an example video on this topic. Watch both of those before you attempt this lab, if you get confused easily. All right, so that's the point of this lab. So at the end of this experiment, you should come up with an empirical formula. Now, there's two kinds of errors that typically happen with this lab. The first error is that people don't heat their magnesium long enough. This usually leads to not enough oxygen getting mixed in. And so you end up having too much magnesium that never reacted. This is one of the errors. It ends up, like I said, giving you too little oxygen. The second error that usually happens is during a step where we add water to wash out any of the other gases that form and other compounds that form, and when we evaporate that water. This often has the effect of making your your substance feel heavier, because the water, if you don't get rid of it all, right, having extra things in there like water in addition to the magnesium and oxygen makes everything appear heavier. This has the effect of making it look like we have more oxygen than we're supposed to. So just to recap, the two errors affect how much oxygen we think we have. The first error makes us think we have not enough oxygen. The second error makes us think we have too much. When you get to the critical thinking questions, there's going to be a question that asks you which error might have happened. And we can figure that out by looking at how much oxygen we have relative to how much magnesium we have. If we have the exact same amounts of each, then either both errors happened and canceled out, or no errors happened. If we end up with less moles of oxygen than magnesium, then it's possible the first error, the heating error, happened. If we end up with more oxygen than magnesium, then it's possible the second error, the extra water error, happened. All right, guys. Good luck.